Hey mathematicians, it's Justin again. Welcome back to the Miaville Art Museum. Mia and I are checking out the next room of the Mathematical Masterpieces exhibit, and this time, it's a tile display. What do you notice about how the shapes are arranged? To me, it looks like one side of the pattern of tiles could be folded in half, like a mirror image. What's going on here? By the end of today's lesson, you'll be able to define what a line of symmetry is, tell whether a shape is symmetrical or asymmetrical, and identify how many lines of symmetry a shape has. Have your guided notes ready, and let's explore the math behind the masterpiece. Imagine folding a piece of paper in half and both sides line up perfectly. That fold line is called a line of symmetry. It divides a shape into two equal parts that are mirror images of each other. What shapes, when folded in half, form two equal mirror image parts, like this piece of paper? Pause the video here to draw any shape that has a line of symmetry in your guided notes. You might have drawn a square, a heart, or even a butterfly's wings. A shape is called symmetrical if it has at least one line of symmetry. We can draw a dotted line on the shape to help us picture the fold and determine whether it's symmetrical or not. What about this shape? Try to imagine folding it. Do both sides match? Not at all. There's no way to divide this shape into two equal halves. That means it's asymmetrical. It has no line of symmetry and can't be split into two equal mirror image parts. This triangle has a line of symmetry down the center. If we fold along that line, both sides match, so it's symmetrical. Check out these other shapes and try to figure out if they're symmetrical or asymmetrical. Circle any shapes that have a line of symmetry and draw the line if you can tell where it would divide the shape into two mirror images. If you're ever unsure, you can always cut the shape out and try folding it to find lines of symmetry. Pause the video here and record your thinking in your guided notes. Can you fold this triangle and make the sides match? Nope. All the sides and angles are different, and it can't be split to create matching halves. This one is asymmetrical. What about the parallelogram? Nope, it doesn't fold over to make mirror images either, so it's also asymmetrical. The double arrow and circle are both symmetrical because I can draw a line of symmetry in both shapes to create mirror image halves. You might have found a different line of symmetry on some of these shapes, though. So, how many lines of symmetry can a shape have? Here's an ordinary rectangle. If we draw a vertical line down the middle, what do you notice when you fold along this line? The sides match exactly. Now, try a horizontal line. That works too. But what about corner to corner? If you fold across a diagonal, the corners don't line up. The sides aren't mirrored, so those don't count. A rectangle has two lines of symmetry, one vertical and one horizontal. How many lines of symmetry does a square have? Pause here to try drawing lines of symmetry vertically, horizontally, and diagonally on the square in your guided notes. Okay, so there's one down the middle, one across, and two diagonals. That's 4 lines of symmetry. Why does a square have more lines of symmetry than a rectangle? Because all the side lengths of a square are equal, the diagonals also make mirror images. Check out this regular hexagon. All 6 sides and angles are the same. Let's test a few lines through opposite corners, through opposite sides, this shape has 6 lines of symmetry, 3 through corners and 3 through sides. Symmetry overload. Try drawing as many lines of symmetry as you can find on a few more polygons. Pause here to draw any lines of symmetry you find. If a shape has no lines of symmetry, just write asymmetrical. A regular heptagon has 7 equal sides, so it has 7 lines of symmetry. And a regular octagon has 8 equal sides, so it has 8 lines of symmetry. What do you notice about regular polygons and their lines of symmetry? Regular polygons with all equal sides and angles have as many lines of symmetry as they have sides. An irregular polygon might have 1 line of symmetry, more than 1, or none at all. It depends on its side lengths, angles, and structure. Which of the irregular polygons were asymmetrical? Yep, this quadrilateral did not have any lines that made the halves match. But this trapezoid does have 1 line of symmetry right down the middle. Any shape could be symmetrical or asymmetrical depending on its side lengths and angles. This one's a little more complex, but if we test a few lines, across, up and down, maybe even diagonally, we can still find symmetry. Sometimes a shape can surprise you and have more lines of symmetry than you expected. With everything you've learned about symmetry, take another look at the tile art from earlier and check how many lines of symmetry you can find in the designs. Some lines of symmetry might run through more than one shape. Focus on how the shapes are arranged together. Can you find any lines that divide the whole design into 2 equal mirror image parts? Pause the video here to identify and draw at least 3 lines of symmetry in the tile art. Try finding lines of symmetry on some of the smaller parts first, and then see if you can find 1 or 2 lines across the whole piece. Record your thinking in your guided notes.
There are several possibilities here, but these are some lines of symmetry that I found. The blue flower shapes have diagonal lines of symmetry, as well as horizontal and vertical lines. And the whole section can be split vertically, horizontally, or diagonally to create symmetry. It's impressive how symmetry shows up in art, design, and even architecture. Whether it's tile art or polygons, symmetry helps create balance and beauty.
So, what have we learned today, besides the fact that these museum tiles are full of secret symmetry? Well, now you know that a line of symmetry divides a shape into 2 equal parts that are mirror images of each other. A shape is symmetrical if it has at least 1 line of symmetry. A shape is asymmetrical if it has no lines of symmetry. And complex shapes may have 1, many, or no symmetry lines, depending on the side lengths, angles, and how the shape fits together. Be sure to complete the practice questions and extension activities that go with this lesson to practice your symmetry skills. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.